Let's look at OpenStax College Physics, Chapter 11, Problem 25. What force must be exerted on the master cylinder of a hydraulic lift to support the weight of a 2,000 kilogram car, a large car, resting on a slave cylinder? The master cylinder has a 2 centimeter diameter and the slave has a 24 centimeter diameter. So let's see what we know and don't know and write it out. I'm going to first point at the hydraulic lift. So this thing here is a hydraulic lift. And basically there is a small cylinder on this side, a larger cylinder on that side. This thing is filled with fluid. And when force is exerted on the small cylinder here, that force is going to be distributed by Pascal's principle throughout the fluid. So the pressure is going to be distributed throughout the fluid, and that pressure is going to be exerted here. There's going to be a force being pushed, and that lifts the car. So basically, when you go to a shop to get your car fixed, you don't see all of this. This is all buried underground. So all that you see is the stuff up there. You drive the car over this platform, and then the mechanic presses the pedal and the car gets lifted. All right, so we are told that the mass of the car is 2,000 kilograms. So M is 2,000 kilograms. And the master cylinder has a 2 centimeter diameter. So this would be the master cylinder. So I'll call this D sub M. And this will be the slave cylinder. So this is D sub S. And we're looking for the force that is exerted on the cylinder. So let me write here D master is, that's the small one, 2 centimeters. And D slave is 24.0 centimeters. So we're looking for the force that has to be exerted onto this master cylinder so that the car gets pushed up. So we want to overcome this 2,000 kilogram mass of the car. So I'm going to say that I'm just looking for the force exerted at the master level. Sounds bizarre, but yeah. All right. So we know that the pressure is distributed uniformly everywhere in the fluid. So what that means is that the pressure here has to be equal to the pressure there. But by definition, pressure is force divided by area. So that means that the pressure at the master, which has to be equal to the pressure at the slave, is going to be force at master divided by area master, and that's going to be equal to force slave divided by area slave. So force master is what we're looking for. So F master is F slave, which is just the weight of the car. So that is W times area master divided by area slave. And that is the weight of the car, which is mg. Area master is pi r squared, but we are given d, so that would be d master squared divided by 4 divided by pi d slave squared divided by 4. So we can cancel out the pi's, we can cancel out the 4's, and we're left with mg d master squared divided by d slave squared. So F master is going to be equal to 2,000 kilograms times 9.8 meters per second squared. And I'm not going to convert the units for the diameters because they're both in centimeters and we're dividing them, so the units drop out. So then we have 2.00 centimeters squared divided by 24.0 centimeters squared, so the centimeters drop out. And when we plug in the numbers, we end up with 136 newtons. So the person only has to exert 136 newtons at this point so that the car gets lifted.